So our topic today, we'll do some review of circuits and discuss the different theorems on circuit analysis and instrumentations, how we use the instruments, how we connect electrical instruments like voltmeter, ammeter, ohmmeter, or watt hour meter, the kilowatt hour meter that you use in your house. And we talk some safety on electricity. So let me share with you a Jamboard. So meron tayong illustrations. So review and circuits. When we see circuit, it is a electrical path where there is source, there is the conductor, often there is a control, and then there is the load, and go back to the source. This is your control, which is often a form of switch. The control do only two things: put it on or off. An on circuit is closed. Off circuit is open. When circuit is closed, electricity flows. When circuit is open, no flow of current. Okay? When we say flow of current, the flow of current follows the path. Review lang ito, ano? This is the current. When the switch is closed, current flows from the source to the load. Now, the source has potential difference. Meaning to say, there is a voltage source, a potential difference, and in the load, there is a voltage drop. Okay? So voltage drop in the load because if the source increases, here potential increases in the voltage drop, that is potential decreases due to the resistance of the load. Okay? So ayan ang very important. Now, we often signify voltage to be in the symbol of E. Often this is an electromotive force or EMF. In the voltage drop, this is simply a voltage drop. When we say voltage drop, the potential drops, of course, and decreases from high to low. That's why we have here from positive to negative. As the current flows through the load or the resistance, the potential decreases. Here, this is the expression, and often the voltage drop is the form of uh, it's often symbolized by VD, which is equal to IR. IR is the voltage drop. Okay? Maliwanag na. So, if this is the resistance and the current flows to that, the direction of current flows to here, that means to say the potential is higher here and the potential is lower. So the voltage drop here is VD is equal to IR, the current times the resistance. But if this is the resistors and the current flows to this direction, okay, and we see that, by the way, the voltage drops from A to B. If this is A, B, and we want to know the voltage okay, so this is drop. If we want to know the drop of voltage from B to A, this is equal to minus IR or negative. Why? Because the potential difference being considered is opposite of the flow of current. Opposite of the current. Ito baga, ini ang voltage drop degree from A to B. Ang voltage drop degree considers from B to A. So this is negative. Pag negative ang direction, it means to say the opposite of drop. Okay. So what is the opposite of drop? Simply increase. This is one. Opposite of drop. So increase in potential. Okay. Take note of the positive value. Here remains the same. Okay. So now we apply in the circuit. This is the Ohm's law. This is the switch. This is the resistance. Coupled with another resistance. Coupled with another resistance. Let's call this R sub 1, R sub 2, R sub 3. The current goes to this direction. I. This is E. We say that the current, let's take Let's call this point A, B, C, D. Okay. So the current I will pass through R sub 1. Let's call it current I sub 1. And some portion will be I sub 2 and I sub 3. We note that at junction B, I sub 1 equals I sub 1 equals I sub 2 plus I sub 3. At B, ito ang node na pinasukan ng current I sub 1. So, the current here will be equal to what enters and equal to what leaves. Anong pumasok, yan ang lalabas. Okay. So, by Ohm's law, the current is proportional to the ratio of the potential difference over the resistance. Okay. This is the potential difference. This is the resistance. This is in current. Okay. Now, if we solve the resistance here, notice that the resistance is composed of R sub 1 in series with two resistors in parallel. Okay, two parallel resistors. Now, what if you want to solve what is the current for each? Okay. To solve for the current, currents, you can say that I sub 1 equals to E over R sub 1 plus R sub 2, R sub 3 over R sub 2 plus R sub 3. Notice that R sub 2 and R sub 3 are in parallel. Okay, parallel. Pag sinabi natin na parallel, the voltage at, ano ba ito? Anong BCD. Okay. We name this BCD. Note that the voltage drop at BD equals voltage drop at BCD. Okay. And what is this voltage drop? The voltage drop here is the current I sub 2, which is equal to I sub 2 R sub 2 also equal to I sub 3 R sub 3. Okay. Now, in this case, take note that I sub 2 and I sub 3 are all coming from I sub 1. Okay. So, I sub 1 equals I sub 2 plus I sub 3. And all the voltages here are the same. The current I sub 1 is going to divide between R sub 2 and R sub 3. So by division, we can get the current at I sub 2 or I sub 3 to be I sub 2, for example, equals I sub 1 times R sub 3 by division I sub 1 R sub 3 all over R sub 2 plus R sub 3. How is this? How can you solve this? Because if you substitute this value, talking for R sub 1 and solving for R sub 3, what's the value? You will notice that it is just divide. Also, I sub 3 equals to I sub 1 times R sub 2 over R sub 2 plus R sub 3. This is by Ohm's law. Okay? Now we have the Kirchhoff's law. If this is the same source, let's say R sub 1, R sub 2, R sub 3, this is A. We can designate I sub 1, I sub 2, I sub 3. Sabi ng Kirchhoff's law, the Kirchhoff's voltage law states that the sum of all voltages in a loop is 0. What is a loop? A loop is a path of current which takes the flow in a complete path going back to the source. So we can say this is loop 1. Okay. Loop 1. We can say this is loop 2. Ayan. Dalawa ang loop na pwedeng kino-consider natin. Meaning to say, in this loop, the current from E sub 1 can either pass some portion through R sub 2 and some portion to R sub 3. Okay. And notice that at point, sabi natin A, B, C, D. Sabi natin, by Kirchhoff's voltage law, the sum of the voltages in the loop is 0. Okay, so if we take that equation of voltages in these two loops, we get voltage loop equation will be E. Now, take note that the current I sub 1 through R sub 1 is a drop. So that is I sub 1, R sub 1, a drop, I sub 2, R sub 2, and go back to the source, which is equal to 0. This is for loop 1. Another loop E is equal to, E minus I sub 1, R sub 1 minus I sub 2, I sub 3, R sub 3 equals to 0. This is for loop 1. You have 3 unknown currents, I sub 1, I sub 2, and I sub 3. So you can say that the Kirchhoff's current law is true for at point B. Sabi na Kirchhoff, the sum of the current at a node is 0. So that means at node B, you have I sub 1 minus I sub 2 minus I sub 3 equals to 0, which makes I sub 1 equals I sub 2 plus I sub 3. Now, by Kirchhoff's law, of voltage loop and current loop, you have 3 equations in Wenon. You have E minus I sub 1, R sub 1 minus I sub 2, R sub 2 equals to 0. Call this equation 1. E is equals to I sub 1, R sub 1 minus I sub 3, R sub 3 equals to 0. Take this equation 2. And you have I sub 1 minus I sub 2 minus I sub 3 equals to 0. Question 3. You have 3 unknowns, 3 equations. So that's this. Solve the problem. Solve for the unknown. You can solve the problems by the unknown by elimination, by matrix, by in your algebra, by determinants. Okay, solve by by elimination, matrix, determinants. Remember this in your algebra. If you are given with a circuit like this, yan, may dalawang source, E sub 1, E sub 2. If this is R sub 1, R sub 2, gawin natin itong E sub 2. R sub 2, R sub 3. So, there is a current here. I sub 2. So, the current here, entering here. Ayan ang. If you do the Kirchhoff's law, maybe Kirchhoff's law, you can consider 2 loops. E sub 1 minus I sub 1, R sub 1 I sub 1 minus R sub 3, I sub 3 equals to 0. You have E sub 2 minus R sub 2, I sub 2 minus R sub 3, I sub 3 equals to 0. And note that the current at node A, sometimes node is called a junction. You get I sub 1 plus I sub 2 minus I sub 3 equals to 0. So you have three equations, you have three unknown, you can solve the problem. Now, similar to Kirchhoff's law, let's call this rule, is the Maxwell's mesh equation. Wherein in the mesh, we draw the circuit as composing of only one current flowing in the loop. Example, this is E1, E2, R1, R2, R3, and Maxwell's equation, you have a mesh current I sub 1, also a mesh current I sub 2. A mesh current flows in a loop so that the sum of the voltages in the loop is 0. Okay. So let's try to see what's the Maxwell mesh equation can result here. R sub 1. So mesh 1 with current I sub 1, mesh 2 at current I sub 2. Sub 1 is sub 2. By Maxwell's mesh equation, you have E sub 1 minus R sub 1, I sub 1 minus I sub para consistent, minus R sub 3, come on, R sub 3, I sub 1. Take note. The current I sub 1, as it passes through R sub 3, causes a drop. Causes a drop. Now, but at the same time, there is also a current through R sub 3 due to I sub 2. And there is also a current drop at that. Okay. So we can say, due to this loop, you have R sub 3 I sub 2 equals to 0. So you have another E sub 2, by the way, this is E sub 1, minus, this is for loop, for mesh 1. For mesh 2, we have E sub 2 minus R sub 2 I sub 2 minus R sub 3 I sub 2 minus I sub 1 R sub 3 equals to 0. Take note of these two terms, especially this. In mesh 1, we included I sub 2. Okay? Ito. It actually, this belongs to the mesh 2. Ito naman, current I sub 1 belongs to mesh 1. But it is in the second equation with second mesh. Okay? So, do not confuse of this. What if we analyze the direction of the current in the other direction? So we consider the mesh I sub 1, consider the mesh I sub 2. Okay, let's see. We have E sub 1 minus R sub 1 I sub 1 minus R sub 3 I sub 1. This time we have plus R sub 3 I sub 2 equals to 0. Also, for E sub 2 equals to R sub 2 I sub 2 minus R sub 3 I sub 2 plus, okay, take note, why plus? Because our direction of the analysis of the current is opposite of the current that is present from the external source. So you have plus R sub 3 I sub 1. By the way, when we begin our by the way, we take note of the direction of the current here, so that beginning from I sub 2, this is actually negative, because from positive to negative, that is negative. So I sub 2, R sub 3, negative. Then I sub 2, R sub 2 is negative. And it encounters a positive increase in potential due to I sub 1 at R sub 3. So that is, yeah. You have two unknowns. Two equations. So you get the I sub 1 and I sub 2. If you get the I sub 1, I sub 2, you probably will get the currents at individual resistor. The question is, what is the current at I sub 3? I sub at R sub 3. Now, what will be the current at R sub 3 when there are two currents flowing in it? Okay, so that we can say that I sub 3 can be equal to I sub 1 minus I sub 2. Okay, now the I sub 2, why we say is equal to this? Because one goes opposite to the other. Now, if I sub 1 is lesser than I sub 2, I sub 3 will be negative. Meaning, the current in it is in the opposite direction. How will it be? Kung mataas ang current ng I sub 2 sa I sub 1, actually the current I sub 3 is from node D to B, pasiring. Siyempre, ababa ang current digdi, mababa ang current sa I sub 1, mataas ang I sub 2, ang potential pataas. Ayan. The actual current will be going up to that direction. Ito ang magdo-dominate na current. Okay, so that is why you get. If I sub 1 is greater than I sub 2, well, that means to say that the positive current will be going from B to D. So the drop here will be determined by the product of I sub 1. And take note that both current I sub 1 and I sub 2 will pose an equal potential drop. Pag minultiply mo I sub 1, R sub 3, they must give the same potential. Okay? Except that, due to the direction of the I sub 2, if it turns out to be greater than I sub 1, by the way, I sub 3, this is the current at resistor 3, R3. Kasi wala tayong current I3. Okay? So that is the current at RT. Ibig sabihin nitong current dito, I sub 3. Okay? Now, when we solve problem, beginning with Ohm's law, Kirchhoff's law, and now we have Maxwell's mesh equation, we must be able to arrive at almost the same answer. Okay. Now, here is another circuit theorem. The Thevenin's theorem. The Thevenin's theorem, if we go back to the original circuit that we analyze, say R sub 1, R sub 2, R sub 3, E. Let's say R sub 3 is the load. So determine what is the current at I sub 3. According to Thevenin's theorem, this circuit can be equal to this circuit. wherein the load is isolated, I sub 3, to be connected to a source which is composed of one single source, the equivalent Thevenin voltage, and the equivalent Thevenin's resistance. Okay? Note, A sub Th, Thevenin's equivalent voltage. The RTH is the Thevenin's equivalent resistance. Okay. Take note that what we did is we isolate the load. We isolate the load. Okay. Now, to find the Thevenin's equivalent voltage. In this example, we isolate the load. This is R sub 3, R sub 1, R sub 2, D. What exists down here will be the Thevenin's equivalent voltage. Ano ang voltage dito? What is that Thevenin's equivalent voltage here? We note that R sub 1 and R sub 2 are just a voltage divider. Voltage divider because some of the voltage will drop at R1 and the other voltage will drop at R2. So that the sum of the voltage E is just equal to IR1 or R2. So when the voltage divider R sub 1 and R sub 2 can be, take note, if we allow, let's say we have a current that flows in this loop. The voltage at ETB at Thevenin's voltage equals to I sub the current at I sub 2 or R sub 2. Let's say, pero ano yun natin para saro natin example. We have let I be the current through R sub 1, R sub 2. So that I equals to E over R sub 1 plus R sub 2. But we know that the current, total current from here is actually equal to of course this much. But we also know that the voltage E is equal to the drops R sub 1 at R sub 2. So we have I times R sub 1 plus I R sub 2. And knowing that this is equal to this, so we get the value, the voltage drop at B1, let's call this B1, B2 from here. That's B2. So this is actually B1 plus B2. Since the current at R sub 1, R sub 1 is equal, so we have the total current I equals to current at R sub 1 equals to current I sub 2. So to find out the current, you have yun. We get I sub 1 by the way. Now, with these three equations, this one, this sub 1, and this one, we can say that the voltage drop let's say here, so there is B sub 1 here, R2, so this we can say that B sub 1 equals E times R sub 2 all over R sub 1 plus R sub 2. Also, B sub 2 equals to E times R sub 1 over R sub 1 plus R sub 2. Therefore, from the circuit, this is the E Thevenin's. We can say that the E Thevenin's voltage equals to E times R sub 1 all over R sub 1 plus R sub 2. Okay. Let's say that this is 2 ohms, 3 ohms, 4 ohms. It says 9 volts. How much current? Hindi pa na madali. So, for the Thevenin's equivalent resistance, you have the source, you have the this is the equivalent resistance. By the way, the Thevenin's equivalent resistance and voltages are seen at the terminal where the load is disconnected. Okay. You note that Thevenin's equivalent voltage and resistance is seen at the terminal. May connection. Terminal, hindi thermal. At the terminal where the load is disconnected. Okay, so ayan. Now, this is the resistance of the equivalent. To find the resistance of equivalent, we short circuit the source. So in this case, this will be like this. The load here is short circuited. So here, the source short circuited. Kapag short circuit mo yan, walang potential. So here you can say that the R Thevenin's equals to R1, R2 over R1 plus R2. You can now draw the ano to, may value na. Wala pa. O sige, kaganta ki value. Let's say this is 9 volts. 2 ohms, 3 ohms, and the load is 4 ohms. What is the current at 4 ohms? Okay. So we solve by Thevenin's. First, we draw the equivalent circuit. So when we draw the equivalent circuit, the 4 ohms is isolated. ET, Thevenin's equals 9 volts times 2 ohms over 2 plus 3 equals, ilan yan? Clear 2 times 9 divided by 5, 3.6. This is 3.6 volts. So this is actually 3.6 volts. The RThevenin equals 2 times 3 over 2 plus 3 equals. That's 1.2. So this is 1.2 ohms. So current isophore equals A Thevenins over R Thevenins plus 4 ohms. Okay, so you have I sub 4 equals 3.6 over 1.2 plus 4 ohms. That's equal to 3.6 over 5.2. It's 0.69. This is amperes. Okay. Now I want you in your seat do the work in the same circuit. Seat work. This is 2 ohms, 3 ohms, 4 ohms. Okay, this is 9 volts, 12 volts. So what is the current at I sub 4? Okay. It's 10:20. Maybe I'll give you 15 minutes. We'll go back at 10:30, maybe 10 minutes. Or 15 minutes. At 10:35, we'll go back to continue. I want you to find the current, make an exercise to find the current at I sub 4. Okay? Okay ba? 15 minutes lang. Tara. Tala yan. Saan?
Naka-off ang mic mo dyan sa
Ha?
ang mic mo dyan.
Saan?
Dyan sa online.
Natatanda na mo. Dae?
Nadadamo kita kaya gusto yan.
Ano?
Nadadamo ba yan sa mga eskwela mo?
But by solving it with Theorems theorem.
7.52 amperes, sir.
If you compare it by the Kirchhoff's law, Maxwell's equation, you can check the accuracy, hoping that if the analysis is correct, the result will be the same. Now, another similar approach in circuit analysis is the so-called the superposition theorem. Not yet. Meron tayong Norton's theorem. Okay? So the Norton's the Norton theorem similar to the Thevenin's theorem in such a way that they are two terminal networks that is being replaced by a single network in which also a two terminal network. So let's adopt the same circuit diagram. This is the voltage E, R sub 1, R sub 2. Let's put value here instead of just the name of the element. Let's say this is 12 volts. This is 2 ohms. This is 3 ohms. And connected is the load 4 ohms. Now we have to find the current at the 4 ohm resistor by Norton's theorem. The Norton's theorem presents us an equivalent circuit which is composed of current source in parallel with the Norton's equivalent resistance, and the load is isolated to appear to be connected to the terminal where the equivalent circuit of Norton appears. So this is the 4 ohms. This is the Norton's equivalent resistance, and this is the Norton's equivalent current. Let's just designate this as isob NR, Norton. Okay. Norton's equivalent current. Take note that here, what will provides us the solution in finding the current at the load resistor is by current division. In the Thevenin's theorem, we have the voltage division. Here, it will be the current division. The current division will take place between the current coming from the source and through the equivalent resistance and the load resistance. So let's see how this is going to work. So first we isolate equivalent current. Okay. So if this is 12 volts, we take note this is A, B. Okay. So this is A, B. The Norton's equivalent current. We remove the resistor and then short circuit the terminal and get the current there. So we have 12 volts, 2 ohms, 3 ohms, 3 ohms, 2 ohms, 3 ohms, and short circuit it. Okay, so we short circuit the. So when the short circuit now appears at A and B, take note that the 3 ohm resistor is already short circuited. There will be no more current going to flow at 3 ohms. I here will be equal to 0 because most of the current here will be, this is the I Norton's equivalent. Okay. 0 na yan kasi sinort circuit mo yan, di ba? It will be 0. Therefore, that's the current ISO 4. Again, this is 2 ohms. Ito ay 3 ohms. Ilang volts bang designate natin? 12 volts. 2, 3, okay. 2, 3. So this is 12 volts. Now, by short circuiting it, we have I sub Norton equals to 12 volts over 2 ohms plus 0 ohms. 0 ito kasi mangyari ito, pag sinort circuit mo na ito, the resistance here will be 0. Okay, so the Norton current equals 6 amperes. Okay, so this is 6. What is now the Norton's resistance? Will be short-circuiting the source. And then look at the resistance as seen at the load terminal. So the circuit now will appear to be the short-circuited load, source, short-circuited source. When the source is short-circuited, that means the potential difference is zero. Its resistance is zero. So the Norton's equivalent resistance equals, this is 2 ohms, this is 3 ohms. So 2 by 3 over 2 plus 3 equals 1.2 ohms. Di ba? 6 over 5, 0.2 ohms. So we can now put the value, this is 1.2 ohms. So that the current at I sub 4 equals I sub Norton's current times R Norton R load by R Norton plus R load. So you have I sub 4 equals 6 amperes ba? 6 over 6 amperes over 1.2 plus 4 ohms. Hindi load, hindi because that is a voltage current division. So ang figure niya this is 6 amperes, 1.2. So therefore the current of 6 amperes in the 4 ohms will be equal to 4 ohms. 6 times 1.2 hindi 4. 1.2. We have, ilan ba yan? Calculator ko, cellphone lang. 6 times 1.2 divided by 5.2. That is equal to 1.38 amperes. Now, how much current flows into the Norton's current? Of course, bigger current will flow into equivalent circuit, the Norton circuit. Take note that if you cross-check at the appearance of the original circuit, ito, tingnan mo yung original circuit, talagang mas konti lang ang dadaan sa I sub 4 because the resistance is greatest among all the three resistances. Kaya maliit lang. Oh, okay. Now, what about if this given circuit is this one? This is 9 volt, for example, 2 ohms, 4 ohms. Give this 12 volts. Then this is 3 ohms. What is the current at I sub 4? Ano ba ang current? by Norton, ang Norton's theorem, we determine the equivalent current source. What will this be? First, if we short circuit the 4 ohm resistor, this is 2, this is 9, 3, 12. So 3 and 12. What will be the currents going through the short circuit leg? What will be the current going through the short circuit leg? Pwede mong i-drawing ini na garong two independent sources. Yan, di ba? Ayan o. Oh, yan. Paghatian mo yan kasi zero resistance na, di ba? 2 ohms. 9 volts. Oh, hinati mo kasi short circuit na, walang nang resistance. Oh. Pwede bagang hilingon mo yan na araw ka yan, 12, 3. So what will the current here? The current here will be the current from the 9 volt source plus the current at the 12 volt source. Nadadangog ako? Hello? Garong mayo akong audio, ano?
Naririnig po, sir.
Okay. Naka-on pala calculator ko sa... Okay. Kaya pala. Ipisi nandito sa high-tech. Alright. Hindi, nag-present natin yung Jamboard. So, here is now, you have the current at the short circuited terminal, called this AB. The current at AB, which is the current at Norton actually. The current at the Norton equivalent will be 9 volts over 2 plus 12 volts over 3. So this is 4.5 plus 4. So you have 8.5 amperes. So this is 8.5 amperes. And what is now the equivalent resistance? Continuation Norton's theorem. So, saan na tayo? 9 volts, 2 ohms. This is 3 ohms, 12 volts. Ngayon, our equivalent resistance will be by short circuiting, you open circuit the 4 ohm resistor and short circuit the sources. So, yeah. So you have the circuit. Two ohms, 3 ohms. This is AB. So that RAB is actually the Norton equivalence resistance. So in this case, Norton's equivalent resistance equal to 2. Nakaparallel, di ba? Parallel 2, 3 over 2 plus 3. This is 1.2 ohms. Pwede mo kaya ining hilingon na araw ka ini. Oh. Di ba? Kung ito ang A. Ito ang B. Ito ang C. BC naghilingan. BC. So B. A. Ayan. So parallel. This is 2 ohms. Sometimes it's confusing to look at the configuration of resistance. It's confusing, but if you try to reduce it to a circuit which makes you see it easier in the way that it will appear, then it's easy to, so ito yan, kaya ang equivalent ang, so you now can solve the 1.2 4 ohms. So this is ISO 4. The current here is, ano ba yung current na kuha natin? $8.5 to get the current of 8.5. 8.5 amperes, 1.2. Okay, so I sub 4 equals to 1.2, 8.5 times 1.2 over 1.2 plus 4 equals ganyan. 8.5 times 1.2 divided by 5.2. 1.96 ampere. So that's the current at the four ohms resistor. Okay. Now we have another theorem, the superposition. Let's take the same circuit. This is 9 volts. Take note of the signs of the polarity of battery, which are arbitrary. It can happen that the battery actually is connected on with the terminals opposite as. Pwede rin kasi i-connect ang battery na ini positive, ini negative. O, pwede yan. Basta sundan mo sana ang voltage increase or decrease. So, let's take, at the moment, let's take this to be. So, positive, negative. The superposition theorem says that if this is 9 volts, this is 12 volts, and this 2 ohms, 3 ohms, and 4 ohms, the current going through the 4 ohms are the composite currents from the two sources. Kung igwa pang ibang sources, halimbawa kinaagan mo pa digdig, meron pag-araray na maaga dyan. Pero let's take a simple circuit at the moment para hindi mag-complicate. We're just emphasizing the understanding of the principle. The principle says that all of the sources contributes current through the element. Kaya sabi ng Turbulence, Nortons, lahat naman na sources magko-contribute ng source, except the approach in the superposition theorem is different. Sabi niya ng superposition theorem, if there is a current coming from the 9 volts, let's call this I at 9 volts, I at from 12 volt supply, there will be a current at sabihin na lang natin ito. Sabihin na natin ito I sub 2. Ito I sub 3. Kasi parehas naman. Just to designate, the I sub 3 is directly coming from the 12 volts, passes through the 12 volts. In series naman yan. So whatever current passes through the source will be the same current that will pass through the resistance in series with it. So I sub 2, I sub 3, by the way. I sub 3 here. I sub 3 is the same current from I sub 12. Is 12 volts. I sub 2, the same current coming from the 9 volt source. So sabi ng superposition theorem, we can take I sub 2 at the moment by short-circuiting the 12, 12 volts supply. Okay, the 12 volt supply we get to short-circuited ng 12, 3, 4. So we can call this I sub 2 prime, I sub 3 prime, I sub 4 prime. So you can get now the equivalent I sub 2 and I sub 4. If we redraw again the circuit, short-circuiting the other source, the 9 volt source this time, considering only the 12 volt source, 12 volts, 3 ohms, 2 ohms, 4 ohms, we have a current that is opposite in direction coming from the 12 volts. So let's call this I sub 2 prime prime. This is I sub 3 prime prime. This is I sub 4 prime prime. Okay, so we get take a note, take a look at the notes here. You have I sub 2, I sub 3 prime. Now we have I sub 2, I sub 3, I sub 4 prime. Solving all the currents, all these currents, you can say that I sub 2 equals to I sub 2 prime plus, this time, if you take a look at the direction of the current, that's physically opposite to the direction of the I sub 2. So we consider this to be in the opposite direction. So this is minus I sub 2 prime prime. Or simply, let's say, this is negative minus I sub 2 kasi opposite. Ganon din mangyari niya. Okay. So I sub 2 prime minus I sub 2 prime prime, that is I sub 2. I sub 3 equals I sub 3 prime minus I sub 3 prime prime. I sub 4. Can you say I sub 4 to be a composite of I sub 2 and I sub 3? Let's say, because the current in this case is in the same direction, all going down in this case. Here going down. Siyempre pasiring siya. Yun naman pasiring going down. Let's say that is I sub 4 prime plus I sub 4 prime prime. That's the superposition theorem. All right? Now, ano pang na-miss natin? Later on when we're supposed to discuss the Y delta, pero wag na muna. Kasi ang Y delta walang so much application for direct current. Okay? Anyway, your advanced study, kasi i-discuss natin yun pag yaon kita sa alternating current. alternating current kasi in the alternating current, the Y delta connection is being used. So sabihin na lang natin study the one maximum power transfer to the Y delta transformation. Ang Y araw yang kaini because in a three-phase system in electrical network there are three lines often in the system for big power network. So let's say this is line 1, line 2, line 3. This is R1, R2, R3. This star connection has an equivalent terminal value as if it is connected in delta. This is the Y, this is the delta. So let's say this is R1, R2, R3. But at the moment, kayo na mag-adal muna. So you study also maximum power transfer, knowing that what will be the maximum value of power that can be obtained from the source into the load. Okay. Let's discuss electrical instruments. Often there are two types of electrical instruments. The basic instruments. The basic instruments will measure your voltage or voltmeter. Another parameter is the ampere meter, or we call it ammeter. And there is resistance, you call it ohm meter. Remember that every electrical network, whenever current flows in a network, in a conductor, the current is always accompanied with magnetic field. Okay? It is always accompanied with magnetic field. So, it is possible to measure the quantity or the magnitude of the rate of flow of current by measuring the magnitude of the magnetic field that is created. Right? Diba sabi natin, if this is the north, this is the south, there is a field in the direction of from north to south. So that if there is a coil here, okay, and then you introduce current in the coil, the tendency is that the current to develop a magnetic field. This magnetic field, it's either will align with the field that is external to it. Okay? So pag ito, pinasukan mo ng current, the tendency of the coil that is under the influence of the magnetic field okay, ganun, is to align, okay, mag-deflect. From there, it will deflect. Diba sa yung analysis natin, if this is a magnet, And this is the plane of the coil. There is a current flowing through the coil. The tendency of this is to align perpendicularly. Okay. So if the coil in this time is positioned in this time, in this position, it might be that when it align at the maximum value, it will be now here. So there is a deflection that can reach from 0 to maximum. Now, what makes the proportion out of this instrument? If we connect a spring around here and we suspend the spring, meaning spring na ini, this spring is going to resist the magnetic force that is induced by the current in the coil under the influence of the permanent magnet. So, mangyari, ang tendency ng spring is to bring it to 0, while the magnetic field created by the current in the coil is to bring it to a certain deflection. This is the basic of galvanometer. There is also a so-called the arson ball. Meter. Anyway, dakol pa. Let me look for a in the net. There is a good Uy. Iron instruments that is due to the influence of magnet. So here it is. There is the spring, there is the influence of the solenoid, so that the pointer can deflect according to the intensity of the presence of the magnetic field in the solenoid. Now, here is the principle. If the field is coming from the permanent magnet influences the coil, it's a spring, the pointer will rotate. Okay. So, ayan na yan. Ito na ngayon. So, if the instrument is said to be like this, the current in the field influencing the field that is created by the same current in the coil, in the moving coil, this is the moving coil, will create a deflection. Oh, ito the same, this moving coil. So ito na ngayon. So Hanap pa tayo ng ano to na? Hindi ko nakukuha sa website. Ano to? Mga digital ang nagluluwas. We're not yet ready to understand these digital instruments kasi we are trying to understand the basic. Okay, so here is how the instrument appears. This is actually the construction of the instrument. Notice that the coil is suspended by bearings, these bearings at both ends, and this is under the influence of the permanent magnet. This is the Arson-Ball meter movement. The Arson-Ball meter movement make use of a permanent magnet. Of course, there are two poles, the north and the south poles, and a moving coil like this, where the moving coil here is being maintained to zero position by means of the force of the spring. So here is now the coil, the moving coil is supplied with current from the source. So if the source provides the current through the resistive load, yan, complete circuit na, yan. Notice that the the coil will be forced to move according to the strength of the magnetic field that is generated by the current flowing through it. In this case, the scale is just calibrated into the 5 units. Now, in the circuit, you notice that the resistance in the coil is not going to change. Whatever characteristic resistance there is, or the internal resistance of the coil present in there, that will not be changed. So, in order to be able to measure a higher value of potential or voltage, there is a need to increase the resistance of the load in series with it. Okay? Dapat tataasan mo ang resistance. Anyway, what is important is that the deflection of the moving coil is determined by the current flowing through it. Now, there are two ways to control the current flow. Number one is by varying the potential. Number two, by varying the resistance. And the effect is mainly to vary the current in the coil, so that the current in the coil will only be from 0 to its rated value. The rated value will always be to its maximum deflection. Ayan. Kapag sinobrahan mo ang deflection dyan, siyempre hindi na pero ang coil, and the effect of that is to resist the higher magnetic field. In effect, there is going to be a induced resistance in the coil so that this coil can burn. Okay. Anyway, in principle, this is the arson valve. Okay. So at the moment, this is one thing important to understand, because this is the basis of designing the measurement of voltages and current. Even in the design of digital instrument circuit, this is still the same consideration and is taken, except that in the digital instrument there is no more magnet necessary. All there is are the quantification or quantizing of the magnitude converted into a digital value and then reconverted to a numerical value to be displayed. Pero ito inimo na para maintindihan ta ano ang. Okay, so take note, the moving coil has a definite value of allowable current. Okay, so ito na. So if you are going to measure a potential, that potential should be within the reach of the current that will flow in the resistance, which is limited by the resistance of the load. Okay, so in this case, okay, so if this is the line and this is the load, we want to measure the voltage at the load, how many volts, and how many ampere. So we connect here a
Good morning po,
voltmeter.
sir.
Hello?
Hindi ka po, sir, naka-share screen po.
Ano?
Hindi ka po, sir, naka-share.
Yes. Sorry. All right. I forgot to. Ito si Jam. Okay.
Sige lang po, sir. Okay lang po.
Ayan. Okay. Yan. So this is the line. This is the voltmeter. And we want to measure the current. We have to insert the ammeter. This is the ampere meter. And in this case, the line should not be directly to the load. All the lines should pass through the ampere meter. Okay? Now, take note that the voltmeter, yung voltmeter baga kanina, ito na yung coil, ano? So, let's say just represent this the coil. I-represent na lang natin. Kumbaga, ito na yung coil ng voltmeter. So, you want to measure different values on the line. So you have a selector switch so that you can select different resistances that, so pwede mong ma-select yan. Let's say this is the R1, R2, R3, and so on. Para ma-measure mo ang deflection without burning the coil, because the coil will be limited, the current in the coil will be limited in the resistance network. Although, meron pang tinatawag na bridge network, saka na natin yon. Ito na muna yung principle. You vary the value of the resistance or of the path of the current that is going to the coil. So the resistors selects the range of the volts to be measured. Note that if the voltage is high, you select the higher resistance. O yan, mataas ang resistance, select mo. Habang kung mababa lang ang voltage mo dito, ito yung volt, o di mababa lang resistance. Making note that this is the coil resistance. This is the you select the switch. So that the current in the coil, eyes of the coil, will be in the source A. And the resistance R sub 1, R sub 2, R sub 3. So I at the coil will be equal to E over the R sub X. What is resistance that is selected? Noting that the current will deflect from zero to maximum deflection. Okay? Now, the same coil can be used to measure the current. How? Uh, if this is the line going into the load, you can put shunt resistors. You call this shunt resistor. So this is the voltage at the source, E. The current coming from the source going into the load will be equal to the current in the coil and the current into the shunt. So the current to the load equals to the current at the source equals to the current at the shunt or the coil plus current at the shunt. Now, by putting a switch this, okay. Let's take a look now that you have several options. You have shunt number 1, shunt number 2, shunt number 3. So by simple Ohm's law or the previous circuit analysis we've been talking about, you can make use of the voltmeter. Kanino bagay natin voltmeter? Into an ammeter. This is an ammeter to measure current. Take note that the current being measured in the voltmeter by the voltmeter used to be is only a portion of the current. Bakit? Some portion of the current will go through shunt number 1, some will be to shunt number 2, shunt number 3. That's why the total to the load is the coil at the coil here plus the, you can now determine what will be the shunt that can be in proportion to make a maximum deflection at the load at the instrument. Take note here that between the shunt and the coil there exists a voltage which can be considered a voltage drop, or this is the voltage along the shunt. O voltage drop yan. Kasi pag binultiply mo ang current doon sa shunt, the voltage at the shunt equals to the current at the shunt times the resistance of the shunt. you can now make the proportion of the voltage at the meter. Or remember also that the voltage of the shunt is also the voltage at the coil. Oh. So this is equal to the current at the coil times the voltage, the resistance of the coil. Remember that the resistance in the coil here is a direct current resistance. Or as a matter of fact, you can insert a resistor here in order to increase the potential drop across so that you can measure the voltage with higher value. Okay. So now by redrawing the circuit, we measure the current along the line, and we measure the voltage across the line. So this is V, this is the volt, this is the load. The load voltage, what exists at the load is the voltage seen by the instrument. What exists at current at the load is the current seen by the instrument. So, ganun yan. Now, you know that power, electrical power, is the product of the voltage times ampere current. Or this is the watts time equals to volt times ampere. The product of this will be volt and ampere will be the product of the product. You notice how do you measure energy? Electrical energy, therefore, is often energy is expressed in joules. In mechanical term, the joule is the equivalent unit of energy, but in electrical energy, you express this is in watt hour, or this is your watt times time. Sometimes this can be watt hour or watt second. Watt second. Watt time second. Knowing that power equals to the energy per unit time. Sabi mo, power is the rate of doing work. Energy sometimes is work. So, rate of doing work. Meaning to say, how do you do it over time in a period of time? How many joules you spend? So that's the watt that you exerted. To measure this, how are you now going to measure the time? Because the time now is involved here, so that in a duration in the bracket of time, you've got to measure how much energy is spent. There comes now the combination of the voltmeter and the ammeter is made. We have now the kilowatt hour meter. The kilowatt hour meter has two sets of electromagnets. Na listen natin. Okay. So, ito ng diagram. Sabi natin, there is a need to measure the current. So, knowing that current will induce magnet, so two sets of electromagnets are placed. A magnet that is okay. So this is now the load. Okay, that's the load. So the current goes to the load. The current here from the source goes to the current in the coil, meaning this is the current coil. This is the potential coil. So what is the purpose of generating magnetic field? That is due to the flow of the current in this coil and due to the flow of current in this potential coil. Take note, this is a potential coil because it is connected across the line. This is a current coil because it is connected along the line. Take note the difference. Coil, the current coil is along the line. Okay. This is across the line. Ito. Ngayon, pag kinagan mo digdi disc, let's say an aluminum disc, the magnets coming from the field generated by the current in the line will cause the disc to rotate. Yan. Umiikot na yung disc. Pag ikot ng disc, nakakonect yan sa mechanical device na binibilang that is connected to a gear so that the gear will display in mga dial baga dyan. Ayan. 0, 1, 2, 3, 9, 0, 1, 2, 9. Yan. Mga dial. Ayan. Pag ikot niyan, iikot ito, magre-register. Kung kaya, alam mo ngayon kung paano dadayain ang metro. Okay. Okay? Ano, are you still interested to learn how to temper your kilowatt-hour meter? Paano maghabon ng kuryente?
Yes po,
Are
sir.
you interested? Wala
Yes
na.
po.
Ano?
Yes po, sir.
Dikit na lang 16 na lang ako. Gusto talaga nindo makaukod kung paano maghabon. Tatanagulo ka. Right. It's important to know how pilferage can be done. I'm going to teach you for the purpose of understanding it, how ordinarily that is it's being done. Okay? in this, I am not going to teach you how it's being done in order to inspire you to rob electricity. Hindi. Tinuturuan kita para alam mo kung paano ginagawa. Para pag nakita mo yung kapitbahay mo na gano'n ng kilowatt-hour meter, alam mo na. Okay? Mari mong isumbong, tapos mag-away na lang kayo. Okay? But that's also a moral responsibility to watch what others are doing, because if others are filtering the kilowatt-hour meter, don't you know, you are part of the one who is paying part of their bill. So, kailangan mo na. Okay. So, ganito yan. Ito baga yung poste. Ito yung bahay mo. Oh, may dua baga digdi. Ano niya? Naka-connector dyan. Tapos, malawag yan sa metro. Kasi rin na duman sa harong mo. Sa switch, may switch baga dyan. Ayan. Tapos pa rin sa mga ilaw. Okay, pasirin sa aircon. Ayan, pasiram-siram kaya tinakbo na ng kuryente. Okay, the 0 volts to 20 volts. Ini mga yaon digdi. This is 220 volts at this is 220. Ito ang nandito, this is 13,200 volts. Okay, hindi na sa taas kan. How does it work? So, ang connection ng kilowatt-hour meter ay ganito na nga. Ito pupunta sa coil, current coil, pupunta na sa terminal mo. Tapos may yung potential coil nako-connect dito sa kuan. Okay. In order to defeat the magnet, ang ginigibo ninda, pinuputol ini. Pinupasirin sa arong. Puputulin nila yan. Tapos maglalagay ng jumper. Yan ang tinatawag na jumper papunta doon. Okay? So no more current going through the current coil. Zero. Hindi na iikot ang kontador kasi napunda na doon sa jumper. Okay? Kaya pasirin na sa arong mo. Libre ka na. Hindi na mag-iikot. Okay, so ganyan lang yan kasimple. Ang iba naman, ang ginagawa, sinisira ito. Kung anong paraan, kung ano na lang ginagawa. Kung ano lang ginagawa para lang hindi umikot. Ang importante dito, paano mo gagawin hindi iikot? Pag hindi yan umikot, hindi talaga magre-register yan. Okay? So yan, ganyan yan. Jumper. Tinuruan kita kasi pag nahuli ka, kasama ako sa magte-testify sa iyo para makulong ka. Kasi tinuruan kita para alam mo kung sino nagnanakaw ng kuryente. Pero pag ginamit mo ito para ikaw na magnakaw, tapos ka sa akin. I am going to testify that I taught you how to rob electric power in order that you know who are those who are pilfers of electricity, because you know, ang paghaabon kang kuryente sa kooperatiba ay nagsasuffer ang kabus na member. Why? Because the losses Siyempre ini, ang energy kay any day na magre-register sa imo, but this is going to register sa energy doon sa cooperative. So, who pays your bill will be the people who are paying the right bill. Ikaw, ang babayadan mo, portion sana. Okay? So, anyway, ganyan ang ginagawa nila. Maski pa ini digital or whatever, ilis na ginagibo nila, jumper. Sometimes it is sad na ini ang harong mo, kataid mong harong, igwa man siya nin metro dyan, pali duman sa kuryente, ini igwa man pasirin duman. Ini ko nakiagi ini digdi, ini mako anin duman, siring dyan. Alright? So, ngunyan, ang ginibo, ini mga metro yan na digdi. Yan na dyan. Kaya kung ang ginibo niya, nagkuwasa dyan, so konsumo mo, ma-register sa iya. Hirak man. Okay? I think next meeting we'll discuss electrical safety, and then the nature of alternating current. Next meeting, topics will be inductance muna, or capacitance. Wag na muna yung alternating. We first have to understand the characteristic of an inductance. What is an inductance? How capacitor works? What's the purpose of the capacitor? In which part of the circuit they can be found? What are the effects of their in the presence in the circuit? How they behave? How current is being influenced by the presence of the capacitance or inductance in the circuit. So these are the two topics we'll try to discuss next meeting. So after we discuss this, we'll then discuss the topics on alternating currents. Yun na pala unahin natin. Okay? So it's now 4 minutes before 12. I don't have to bother you so much because I understand a 15 minutes lecture is more than enough to concentrate your focus. If a 3-hour is most likely will tire you. Marikan sa nagle-lecture, okay sana. Sa nagpaparataram, okay sana. Sa nagdadangog, talaga mapagal. Aso ako mag-attender ako kay lecture. Masiki ito pang aki ako. Maybe as young as you in my time, my 10-minute attendance in the lecture is already burdensome. Mahirap na sa akin. You know, ako na-experience ko din sa Angarog sa Indo. Ang 5 minutos nga na minsan kayo ito, grabe na, pagal na akong magdangog. Maray panday na sana. Bahala na akong mag-adalkan sa diri ko. Okay, so I'd like to thank you for being present today. How many of us?